I think it's a fun problem. The friction provides the force of a car, not the actual engine, the friction of the tire for the car. And you want to go from 0 to some speed. I think on this problem I have 70 miles per hour. So the first thing you want to do is, let's think about this. You're trying to figure out, um, what's this asking for? It's asking for how much time. So how much time is it going to take, the minimum amount of time for it to go from 0 to some speed? Well, this is going to be a kinematics equation problem, right? So we know that V1 equals 0, and V2 equals so many miles per hour. Now, I had 80 miles per hour when I was doing the problem, but I had to convert. I went from miles to kilometers, and then I went from hours to seconds. There's 3,600 seconds in an hour, and there's 1.609 kilometers in 1 mile. No, 1609 meters, 1609 meters in a mile. Anyways, you need to get this as your velocity too, right? And what you're trying to find is time, right? So time is your question mark. What else do we know? We know, we know some force stuff, right? So we've got in a car, right, with some mass, and they didn't give you the weight. Again, super important. Sometimes they don't give you the weight because the weight's actually going to cancel out. But if you don't do this, I find it just easiest to make an assumption that the car is going to equal to 1,000 kilograms times 9.8, which then makes the normal force the same as the weight. Got it? So what we want to do is we want to figure out how much acceleration I need to get this to work. So we know the coefficient of static friction is 1.0 and kinetic is 0.8. Now it's starting from rest, so the coefficient of kinetic friction is not important because you've got these forces. This is the force of friction, and this is the force of propulsion or moving to the right. And to get it going, you're just going to plug it in. You're going to say the force of friction is equal to your weight. Technically it's 1.0 times the normal force, which is going to be this number here, right? And then you can find the force of friction. And then you're going to set that force of friction equal to the mass times the acceleration. And of course, if we put 1,000 back in here, the 1,000 will cancel, and you can find what the acceleration is. Then you'll know an A from this problem here. And at that point, we can solve for time. Now, in my world of kinematics equations, I would use the equations V2 equals V1 plus AT. And you're trying to solve for T. What is V2? You have to convert to meters per second over here. What is V1? That's 0. What is A? That's what you got right here, right? And you're solving for T.